accumulated all our images, and we have checked to see which ones we want to keep and which ones we don't want to use because of clouds or satellites or whatever. And the next thing we need to do is calibrate our images. So those of you that have done astrophotography projects, you've done this too. We're going to apply different types of calibration frames to the image: bias frame, dark frame, and flat field frame. The bias frame is going to take out the readout noise of the camera. The dark frame is going to take out overcharged pixels, hot pixels that accumulate on the chip as the camera is left open for a certain period of time. Those charges can build up on certain pixels, and we want to make sure that we compensate for those. And then finally, flat field, which takes care of any dust or scratches in any of the surfaces, the mirrors, the camera, the filter, whatever. And so we need to apply those because, again, we want to have the most pristine, most accurate images we can have in order to get really precise measurements. So we're going to, for the first time, use AstroImageJ. AstroImageJ is this icon over here that looks like Saturn. We're going to open that up. And when it opens, we've got a bunch of icons and some menu items. The first icon we want to go to is we want to go to the 1 second from the right. This thing that looks like little calipers here. This is the coordinate converter tool. And we want to check and make sure that SPARQ Observatory is listed as the correct observatory ID, and here it is. There's a drop-down menu of different observatories around the world. SPARQ Observatory is in there. The reason we need to have this is because this way the software has our location, has our latitude and longitude, and also our altitude of the observatory. And the reason it needs to know this is one of the things it wants to calculate is it wants to calculate the air mass, how much atmosphere we're looking through. And when we have the air mass calculated, that's something that AAVSO requires to have as part of our data when we send in our results. They want to know what the air mass is. So we need to make sure that this is set correctly. Pretty easy. If it's not there, just do the drop down and go to SPARQ Observatory. And there we have it, and then everything else will be filled in automatically as we go. So we have that okay. We're going to go ahead and close the coordinate converter, and now we're going to set up our calibration routine. This is done with this little icon here, DP, and it stands for a data processor. This is the CCD data processor tool. And we've got a couple boxes. The first box up here is where we're going to navigate to the images that we've kept. These are still raw images, but they're the images that we wanted to keep. And then we have our bias section, dark section, and flat section. And then we will be able to run this, and AstroImageJ, AIJ will go through all of our images and calibrate them for us and save them in a folder. So the first thing we need to do is navigate. We're going to do just the B's and the blue filter one. So we've got enable and sort number up here. We're going to go to this folder icon here, and we're going to navigate to our B folder. And we don't need to go through the whole thing here, but this is our B folder here. We're going to open it, and you'll see that nothing is listed because all AIJ is interested in is anything that ends with the .fit. That's the file that we've selected. So it's got a wildcard .fit. So anything in this folder, even though we can't see the contents of this folder, that have that file format are going to be loaded into AIJ. So we'll go ahead and click select. And when it's done, over here to the far right, there's a totals column for everything. And this is telling us that it found 236 images from the B folder that have the file format of FIT. Okay, we have that set up. Next thing we need to do is go ahead and set up our calibration. First thing we want to do is we want to check in to the folder where we have the calibration images. And you can copy them into your own folder, your target folder here if you want to. but we want to use the calibration images that are closest to the time of the raw images being taken. And for us, this is going to be September 9th, 2024. We're going to open that. And the first thing we want to check is we want to check the calibrations masters folder and see if there's anything in there. Because if there is, then we can just use the masters instead of having to essentially build masters from this. But we don't have any, so we're going to go ahead and build the bias. And so we're going to go ahead and check the build box here, and then we're going to go over here to the right, and we're going to navigate to, this is the correct folder. We're going to navigate to the bias folder. Double click it. Again, nothing's going to be there. We can't see the contents. And it's going to load the bias frames that end in .fit again, and it found 50 of them. We also want to have enable over here, and we want to navigate to where enable just build is going to make a master frame, and we're going to want to save it to the calibration masters here. So we're just going to throw that in there, click select, and so now it's going to make a master bias and put that in the calibration masters folder. We're going to do the same thing for dark. Remember that for dark calibration frames, they need to be at least the same exposure time as your raw images. So we did 2-minute exposures. We're going to want to make sure that we look for dark, a dark folder. So we have dark 5 seconds and dark 120 seconds. We're going to use the 120 seconds. That's the 2-minute folder. And again, we can't see the contents, but when we click this, we can go over here and see that it found 20 dark images that are at 120 seconds. We're going to go ahead and click enable and go ahead and keep scale into bias on and navigate to our calibration folders, calibration masters folder, and select. And then the same thing with the flat. So remember with the flat images, we want to make sure that we're using the filter that matches our raw images up here. So we took the images that we're looking at that we're going to calibrate were taken with the blue filter, and we're going to use the flat field frames that were also taken with the blue filter. We're going to go ahead and click build, and we're going to navigate to flat B and open that up. Again, we can't see anything, but it's telling us that it found 25. So we've got 236 raw images that we're going to calibrate, 50 bias frames, 20 dark frames, and 25 flat fields. And we've got enable. These settings are all correct here. And so when we run this, we just have to come down here to start. And we're going to get a log that's going to come up. And it's obviously kind of impossible to kind of keep up with what's going on. If you do get an error, read what the error says and see if you can figure out kind of what's going on. A lot of times it's because it can't find a file or something like that. So what you're seeing now is it's blinking through all the images. It's actually going through each image and applying the calibration frames to each image. So we'll have nicely calibrated images. If you want to know where you are in the process, in the tool, the processor tool down here in the lower right hand corner, it's telling you how many images have been processed and how many remain. And remember that we started out with 236 images, and so we're getting down to the end of it here. So what will happen is that AIJ has created a new folder in your keeping calibrated folder in your B folder that is for calibrated images. So it's all done. We can go ahead and close this image, and the log will come up and it says finish down here. We can get rid of that. And if we look at our folder, and we'll navigate up to our photometry folder, targets, Steve, A, and Lynn, keeping calibrated, and we go to the B folder, you'll see that it has created a new folder within here called calibrated, and within here, here are all our images, and they've added the keyword calibrated after it. So we're all set for the blue. You're going to want to do the same thing for the V images. The only thing that you have to change is, of course, you want to change the input, where are your V raw folders, files that we have in the folder, and then you want to remember to change your flat field from B to V. So that's pretty much it, and we will go ahead, and the next thing we get to do is we get to start doing actual photometry. We've done our imaging to get our raw images. We've done the image approval and rejection, and we have now calibrated them. And now they're as pristine as they're going to be for us, and we're going to go ahead and do the photometry next.